Yeah. Where am I gonna? I could sit in a desk. I'm gonna sit right here. I'm sitting in Ananya's desk. Ananya, if you're listening to this, I'm sitting in your desk. All right, section 5.7. So I'm going to hit a highlight reel of this first, and then we'll go over some homework, and then I'll finish what we're going to do after that, okay? All right, so those of you that are leaving, here's the major key. Do you remember when we did motion back in chapter whatever it was? Yep. Oftentimes we started with our position function, and then if we wanted to get to velocity or acceleration, we had to differentiate to go down. But now we know how to take our antiderivatives. So instead of differentiating to go down, starting with position and going down, a lot of these problems we're going to start with either our acceleration function or our velocity function, and we are going to take our antiderivative or integrate to go up instead. Jay.
If I had actually, you might just talk about this, but if I started out with an acceleration and I had to find a position, would that be the double antiderivative, and then in that would it be like cx plus c?
Well, so let's talk about that. Each time you take your antiderivative, you're going to have a constant of integration, right?
Yeah.
So that will give us what's called a general solution to a differential equation. In order for us to find a particular solution for the differential equation, we have to know some sort of data point. So whether it's an initial condition, which is what it will typically be in this section, the first part at least, or something else, we have to have some sort of data point to find what C is. And then that way we can actually figure out what that particular solution is instead of the general solution. All right, so double antiderivative of acceleration to get to position, okay? All right, so we can move up the list by integrating. Now, do you remember these from science class? Yeah, force of gravity here on Earth. So if I'm using feet per second squared, then it's negative 32. If I'm using meters per second squared, it is negative 9.8. And I'm sure you guys have seen those before, have worked with those before, so we will do the same, okay? So even if I don't know anything about the function itself, I can start with, as long as I know, acceleration, what unit of measure I'm working with, I can start from there and then work my way back up, okay? All right, so let's start basic. This is our velocity function, v of t equals cosine pi t, and then we have the initial condition that s of 0 is equal to 4, okay? So what I want to do is I want to find position. So I need to take the antiderivative of my velocity function in order to find what my position function is. So s of t is going to be the antiderivative of v of t. I can write that if I really want to be exact, but did I just heard a rule being broken in my class? Is that what I just heard unmistakably?
There's no juice.
It's Diet Coke, so there's no sugar. So it's
Oh, that makes it all right. It's not juice. It's anything but water. I don't like anything but water in my class, but I've been...
It's just like chemicals in
Yeah,
water.
what about you? This is 99% water.
Those chemicals are what makes my floor sticky if you guys spill it.
Okay,
Can I bring
Aspartame doesn't make your floor sticky.
This is phenylalanine. So
No.
it's different.
No.
Mine's just like a laundry
No.
list of stuff.
Listen, Ozra, you're the only one that's following the rules right now, so I'm not throwing shade at you. Max and Machi are following the rules.
Wait, Ozra, do you have anything? You just have water.
She's got water. She's good. But she asked about tea. Listen, if you want to see me get mean, spill something on my floor.
Whoa.
Then I'll get mean, okay? Hey, how do I take the antiderivative of this?
Negative sine pi t, something like that.
No, not negative, it's normal.
It is positive, but there's something else along with it.
Plus C.
Oh, plus c.
More than that. Yes, but we call that u substitution integration. I got to do a little u sub because u is pi t.
Oh,
Arf.
would it just be 1 over pi?
Yep.
Okay, well, that's basically what I said.
So pi dt, so then we got to divide by pi,
Sine pi t over pi.
not over pi. Oh, yeah, okay. I put it in front. Over pi would be fine. Yep, either way is cool. Plus c. Gosh. All right. I need to find my c value, so I should plug in the things that I know. So my position is 4 at time t equals 0. So 1 over pi of sine of pi times 0 plus c. Sine of 0 is indeed 0. So then we would just get 0 plus c. So then my c value is equal to 4. So then my position function becomes s of t equals 1 over pi sine of pi t plus 4. Yay. All right, cool. Now, let's do some context. A penny is dropped from a height of 1,250 feet. We want to find the time when it hits the ground and the speed upon impact. I give us our acceleration function, a equals negative 32. They won't always do that in your textbook, so you got to keep that in your mind, that that is our starting point, is our acceleration. What function do we need to get to?
Velocity.
I need to know the velocity, but I also need to know the position as well too, right? To answer part A, find the time when it hits the ground. What do I need to know for that? Need to know the position. And what am I going to do with that position function?
When it gets to 0.
Set it equal to 0. Good. And then speed at impact. That's my velocity at the time that it hits the ground. Yeah. Very good. Cool. So let's start by taking my antiderivative of my acceleration to find what my velocity function is. Negative 32 dt. Hey, that's not bad though. Negative 32 t plus c equals v of t. The only information they gave us was that the penny is dropped. That's important. From a height of 1250. Can we identify what that means? Okay, so S of 0 is 1250. What about V though? Because that's what I'm working with right now. Do I know any? Why is my initial velocity 0?
Yeah, it's not moving.
Because it's dropped.
Yeah.
Very good. So my initial velocity is going to be 0 because my penny was dropped. So then 0 is equal to negative 32 times 0 plus c, which just gives us that c is equal to 0. So then my velocity function is going to be v of t equals, you know what, I'm actually just going to move that down here. V of t is equal to negative 32t. Okay, let's find our position function. So s of t is going to be the antiderivative of v of t, but I'll actually write what v of t is. So negative 32t dt. All right, so antiderivative of negative 32t gives me negative 16t squared plus c. Have we seen that before? Negative 16t squared in our science classes? Physics? Have you guys worked with that at all? Okay. Oh, yeah, okay, that makes sense. And then I need to find what my initial height is, my c value. You guys already told me what that is, 1250, right? How I would do that if I didn't immediately pick up on that is that my initial height is 1250, so I would set that equal to negative 16 times 0 squared plus c, which of course gives me c equals 1250. So then my position function is negative 16t squared plus my initial height of 1250. Now I'm ready to answer my questions. So part A said find when it hits the ground. You guys told me I need to set my position function equal to 0. So then 0 is equal to negative 16t squared plus 1250. Let's move that value over to the left. So then divide by 16 and we get, oh man, 675? 625. 625. What's that?
78.
0.125. 78 and 1/8.
Yeah, 70. So,
78 times 8.
oh, he's doing the thing. He's doing
This is bad math notation. I should write this. 12 squared equals 625 over 8. To Ozra's point, though, I could have just taken the square root, and then I would have gotten a 4 in the denominator. And then I would have, but either way is fine. I like Ozra's answer. However, if we take the square root, I could take the square root of 625 now, right? 6 in one hand, half dozen in the other. Do I want plus or minus? No. So square root of 625 is 25 over square root of 8, which we can take some time to simplify. 2 square root of 2. 25 square root of 2 over 4.
Yes, looks good.
Yay! All right, now that's the time at which it smacks the ground.
Yes.
Part B, we want to find the speed when that happens. So you said plug it into my velocity function, right?
Yeah.
So I need to do v of 25 square root of 2 over 4. So my velocity function was, again, negative 32. So I'm just going to do negative 32 times that value. And we'll talk about that in a second, Jay.
No, I was gonna say a stupid thing. I was gonna say, shouldn't we square it? But then I remembered there's square in the velocity.
All right, so then 32 over 4 is going to give us 8, right?
Yeah.
And then 8 times 25,
8 times 25.
200.
Oh, yeah, yep,
So negative 200 square root of 2.
yeah.
But they asked for what?
The speed.
Yeah,
It's just the absolute value.
right. So then, all right, that would be my velocity, right?
Yeah.
But we want speed. So then we would say that our speed would be equal to the positive version of that. 200 square root of 2 feet per second. That's pretty quick, I think. I don't know. All right, questions there? Cool. Let's take an object and let's throw it up. With a rate of 49 meters per second from a height of 8 meters, find the height position of the object at its highest point. Let's talk about the things we know and what we want to find and how we would find that, okay? Object thrown upward at a rate of 49 meters per second. What is that?
The initial velocity.
Initial velocity, good. So velocity at time 0 is going to equal 49 meters per second. All right. What else do we know? Height at 0, so S of 0 is equal to 8 meters. Cool. We're dealing with meters, so it's going to affect our velocity or our acceleration function that we start with. Let's talk about what we want to, like, how we answer the question, though. Find the height of the object at its highest point.
Okay, Logan, I'm sorry. Dude, Max is over here talking about delinquent things.
All right. Well, right now our attention is delinquent. How do we find the height, the height at its highest point?
Isn't it like, it's like some stupid thing, 2A over B or something, right?
It is, but we'll talk about that in a second. But what would I do?
The derivative when it's equal to 0.
So derivative of position would be velocity. I need to set my velocity equal to 0, which makes sense because when it reaches its apex, what's the velocity at the tip? 0. Okay, so I need to set my velocity equal to 0, but then I need to find the height, so I should also figure out what my,
T value.
yes, okay.
You can plug it into a position.
And then I need to know position, right? So I need to start with acceleration, I need to go all the way to position, okay? All right, now, when I start with my acceleration to figure out my velocity, what do I put inside of my integral?
Isn't it? Yeah, it's 9.8.
9.8. Negative 9.8.
Where's on the street? Making these 10.
Yeah.
False. Not in this class.
Why not?
Because this is math. We're being exact.
On Mr. Shane's class.
Well, listen,
Physics, we are.
Mr. Shane is the GOAT. I get that. However, in this class, what's that?
On the AP test for physics, you don't have.
Not this AP test, my
You
friend.
have to use 9.8.
Not this AP. Yeah.
Okay. That's all right.
Yeah. We'll be fine. So, negative 9.8t plus c. That is our velocity. And then we need to use our initial velocity to actually figure out what our constant of integration is. You guys good?
Goodbye.
I think the homework on the last slide is on the wrong page. It's 367 instead of 387. You'll figure it out.
I'm so sorry. No, I'm so sorry.
Holy crap.
We were doing so good. Okay. No, we weren't. All right, here we go. So then I wrote 49, and I shouldn't have done that. This should be a C here. But C is 49, so maybe that's just what my brain was thinking. Probably. Okay, so then my velocity function is going to be negative 9.8t plus 49. All right, so then now I want, before I set that equal to 0, like I remember that I have to do that, I like finding all of my things first. So I'm going to actually work on finding my position function now, and then I'll go from there. I'm in integral mode right now. Oh yeah, there's a bunch of graphs that I accidentally put in there. It's because I copied everything from a sheet and then just made a new sheet each time, and then that was beyond my view when I was copying it, and I never knew it was there. So.
You never get this. You didn't put it there.
Well, I put it there when I taught you guys. Like every time I make a new lesson, I just duplicate the old sheet and then just like fill in like what's there. But I worked very far to the right that time, so it doesn't matter. I'm spending so much time talking about this. All right, S of t equals, all right, so I'm going to have negative 9.8, but yeah, it's going to be over 2, so let's say negative 4.9, not negative 5, negative 4.9, because we got to use negative 9.8, not 10, and then plus 49t, and then plus c. But our c is 8, so I'd set 8 equal to, and you guys are probably starting to develop the pattern here. We know that c is just going to be 8. Do you guys agree with that? It's the magic of working with a polynomial. But if I do plug in 0 for those values anyways, just to show c is equal to 8, I get that my position function is negative 4.9 t squared plus 49t plus 8. There's something satisfying about like gathering all the information you need first and then being able to answer the problem. I don't know why I enjoy that, but I do. Find the height at the highest point. So I would take the derivative of s of t. I don't need to do that. That's already right there. So then I would set my velocity equal to 0. So then negative 9.8t plus 49 equals 0. Why am I setting that equal to 0? Because again, for my object, my height... Oh my gosh. Oops. The highest point happens when I have a horizontal tangent line, which is when my velocity is equal to 0. So my tangent line is equal to 0. Okay, so I would get 49 equals 9.8t. Divide by 9.8. Oh my gosh, decimal. But it turns out to be a nice number. It's 5. Yay! All right, so 5 seconds. Okay, so then now I need to find the, so that's the time at which it reaches its max height. Let's actually find what the Max Richardson height is. So then I would do S of 5. Negative 4.9 times 5 squared plus 49 times 5 plus 8. I mean, negative 4.9 times 25 plus 49 times 5, which is 245, plus 8. It's like negative 122.5 plus 245 plus 8. Okay. What's happening? Oh yeah, I gotta combine those. So then when you add those together, like 130. I feel like that needs checked. I think it's 130. Okay. I think it's right too. Yeah, because then you would add that and to 245 and 252. Yeah, okay. All right, got it. All right, cool. 130.5 meters. All right, we've seen some patterns develop, so let's just give ourselves some general equations for position and velocity as well too, okay? So if we have what's called uniform acceleration, which is just your object is accelerating at a constant rate, then a lot of our problems will deal with that. So then let's find our general equations for velocity and position as well too. It says velocity and acceleration, but really this should be position. All right, so A of t equals A. V of t is going to equal the antiderivative of A dt. Very simple. V of t is going to equal A times t plus c. Now, our given here, our initial velocity is v with a subscript of 0. We call that v sub naught. So then v sub naught is what we get when we plug 0 in for t, which means my c value is just going to be v sub naught. So then my velocity equation is v of t equals a times t plus my initial velocity. All right, let's find what s of t is. So antiderivative of what we just found, a times t plus v sub 0 dt. So antiderivative there would be a over 2, which we saw already, t squared plus v naught t plus my new constant of integration. But we have the initial condition that s sub 0 equals s sub naught. So s sub naught equals a over 2 times 0 squared plus v sub naught times 0 plus c, just giving us that c is equal to our initial height. All right, which gives us our position function. S of t equals a over 2, our gravity divided in half, force of gravity divided by half, t squared plus our initial velocity times t plus our initial height. And then my velocity function is v of t equals a times t plus our initial velocity. Every time I put that border in there, it reminds me of Elmo. Can you see it?
Because it's a red crayon.
Yeah. No, not necessarily because it's a red crayon. It's just like this is what Elmo's
Oh, it just has
fur, I guess, the texture of Elmo looks like to me. Absolutely not. No, I cannot.
Is the video already too long?
It's not about the video.
Oh, there's another graph on the next page.
Yeah, there is.
Cosine.
Yep, again, sorry about the graphs on there. But, yeah, this question has nothing to do with that. A bus has stopped when a woman is 11 meters from the front door. That doesn't work. The bus then accelerates at a constant rate of 1 meter per second, so uniform acceleration. The woman runs at a constant rate of 5 meters per second. When will the woman catch up to the front door of the bus? All right, so we got a bus and we got a woman, and they're moving. So we want to find, let's look at like what we have, what we want to find, how we answer the question. Okay, bus has stopped when a woman is 11 meters from the front door. That deals with what? Position, velocity, or acceleration? That's position, right? So when we get to position, we'll look back at that sentence. Then the bus then accelerates at a constant rate of 1 meter per second. It's bothering me. Okay, the bus. The bus then accelerates at a constant rate of 1 meter per second. Okay, so then that deals with what? Position, velocity, or acceleration. So my acceleration of my bus is equal to 1 meter per second squared. Per second squared. Okay. All right. The woman runs at a constant rate of 5 meters per second.
So her acceleration is 0.
Her acceleration is 0, but her velocity is 5. And again, because it's meters per second, so that's one way we could tell that that's velocity, and then the other one's acceleration. So velocity of the woman is equal to 5 meters per second. The woman runs at a constant rate of 5 meters per second. Cool, so there's that. When will the woman catch up to the front door of the bus? That deals with what equation or what function? Position, right? What am I going to want to do with my two position functions? They got to be equal. So I got to find the position of my bus, the position of the woman, and I need to set those things equal to each other. And then the timestamp that happens at is when they will catch up with each other. All right, so let's start on this journey. Okay, so velocity of bus is going to be equal to the antiderivative of my acceleration, which is just going to be t plus c. So I got to figure out what my initial velocity is of my bus. 0 because a bus was stopped. Okay, so at time 0, it stopped. So then that's my initial velocity. Good. So what's my c value? Okay, cool. So velocity of bus is just equal to t. Well, let's keep going. Position of bus is going to be the antiderivative of my velocity, which is just going to be 1/2 t squared plus c. Okay, now we're dealing with position. Okay, so that goes back to my first sentence, right? And it says, bus is stopped when a woman is 11 meters behind the front door. So why don't we think about bus as like home base? And that's the bus's initial position, let's just say, is 0. If the bus's initial position is 0, what's the woman's initial position? -11, because it's 11 meters behind the front door, okay? All right, so then we're just going to say the position of the bus at time t is just 1/2 t squared, okay? Because my c value is going to be 0, my initial position is 0. All right, and then let's do the woman things. So then position of the woman at time t is antiderivative of 5 dt. So 5t plus c. And we had some information for initial position, right? What did we say initial position was for the woman? -11. So equals 5 times 0 plus c. We know that c is going to equal -11. So then position of the woman at time t is just 5t minus 11. What do I do with those two things? Set them equal. So then I'm going to have 1/2 t squared equals my position function for the woman. And then I solve. I'm going to multiply everything by 2. T squared equals 10t minus 22. Let's get everything on the same side. Minus 10t plus 22 equals 0. Then what are we going to try to do? Factor. But what multiplies to equal positive 22 but adds to equal -10? Womp womp. So we've got to do what? Yeah, you bet your bottom dollar we do. So then t is equal to 10 plus or minus square root of b squared, which is going to be 10 squared minus 4 times 1 times 22 all over 2. All right, 100 minus 88. 12 over 2. Okay, at least they gave us a nice number. All right, square root of 12 breaks down to what? Good. And then we can divide our values by 2. So then I get 5 plus or minus square root of 3. I get 2 answers there. Let's talk about that. Are they both legit? What do they represent? Why is there 2?
The x-intercepts.
What is the square root of 3? 1.73? I think it's like 1.73.
Wait, why is it?
So then there's 2 positive times, right? So at t equals 5 minus square root of 3, something happens. And then at t equals 5 plus square root of 3, something happens. What happens when t equals 5 minus square root of 3?
They are equal again because the bus is speeding up. If she didn't get on the bus at that point, then she'd still be running.
Right,
And then the bus is still accelerating.
right. So
Wait, what?
the first time is when what happens, Jay?
Okay, let me draw the graph.
I would love for you to stand up and draw the graph. Do you want to do it on here? Do you want to do it on here? Do you want to do it on here for everyone? Take the iPad. The power of the iPad. Jay, everyone,
So,
drawing a graph.
I don't know. This works out in my head, but I don't know if it works out. Hi, everyone. Okay, so the bus. I'm changing this. Okay, so the bus, right? It's like going and it's 0, but then it's going like this. Okay, and the woman is going like, oh, she's actually negative 11. She's going like this. So they meet right here. She's like there, but if she keeps running, there's gonna be a point where the bus meets her again up there.
So why did she just get on the bus with her?
No, she is, but there's 2 solutions because there's 2 intercepts for that system of equations. So she could, or she could get off there too. Or no, that doesn't work out. Never mind. She gets, yeah.
Okay.
And then this one is 5 plus the square root of 3.
Good. Very good. There's 2 intersection points, right?
Yeah.
The bus is out in front at first. The woman catches up with the bus at 5 minus square root of 3. And then what if she just keeps going? She's like, I don't need this bus, right? I'm faster than the bus. The bus is going to catch up at some point.
gonna pass her.
Yeah, the bus is faster.
Yeah, she's running fast.
She's booking it, man. She's booking it. Yeah. So,
It only takes her 5 seconds to catch up with the bus.
dude,
Or no, less than 5 seconds.
she ate her Wheaties that morning.
No, it's going.
That's a really slow acceleration too.
2 meters per second. I feel like
Yeah.
there's a bus going that fast.
It's a bus though, man, you know?
So what is the correct answer?
So woman catches up
It could be the first one.
with
That's when
bus.
she first gets there.
Okay.
I
Yeah,
guess she really could get on at either point. if
Sure.
she wants to.
right.
All a matter of her will.
So the woman catches up with the bus at t equals 5 minus square root of 3, and then at t equals 5 plus square root of 3, the bus catches up with the woman.
Oh my gosh, I get it now.
There it is. It's clicked.
It's insight.
Yep. Ved, you good? Cool. All right. Your homework is as follows. 367, not 387. And then there's a bunch of those situation problems. Gentle reminder, quiz on Thursday. Not on what we did today, on what we did yesterday, which we haven't gone over any homework for that. So if you guys want to see any of that. Tosh put up number 18. 18 is a good one. We can talk about that. But fundamental theorem of calculus was yesterday. We also talked about total area yesterday, which was just absolute value of whatever's inside that integral was total area. And then U sub is what we will do tomorrow. So tomorrow we'll come in. We'll review anything from 5-7 homework that you guys want to see. Some tricky stuff in there. We'll do 5-8. I should finish with enough time for you guys to start working on your homework in class tomorrow. So do that. And then Thursday we'll come in. We'll answer questions on 5.8. You guys will take a quiz. Not a huge one. Probably a 30-minute or something like that. I don't know. And then I'll teach you some content after that. Sound good?